So this is my 51X Hickok tube tester. I usually use this tube tester when I want to test vintage and older tubes. I bring this out. What I've done to it, I replace the capacitors, resistors, calibrate the device to make sure it's functional, cleaned all the pots, lubricated all the moving potentiometers and switches. And as you notice, the 51X has a multi-function device. You can use it as a tube tester, or you can use it to read ohms resistance, DC, AC. But we're not using that function. All I care about is testing the tubes. So that's pretty much how it functions. And on the back of the box, let me just show you real quick. This is the cover for the box. It goes like this. Open it up, and behind the box you can see there is a tube chart. Now this tube chart only has a limited amount of tubes. If you want to test additional tubes, what I do is I download the manual online, and I use either the manual if the tubes are not on this chart, or if I'm lucky enough and I test older vintage tubes that are on this chart. So let me show you how to test a tube, how this works. So what I want to test is a 6v6 tube, which is right here. So I want to test this tube to see if it's functional, if it works. So this tube tester can check for shorts, gassy tubes, and obviously in micro ohms, and not only can test it in micro ohms, it also gives you a good or bad replacement tube indicator on the screen. So let's test this tube. So according to this chart, I want to look for the 6v6, which is, where's 6v6? Down here. So we got to set the parameters on the tube tester to the 6v6, and this is the reading. You need 3000 mutual conductance would be about 3000 would be minimal. So let's test. So the first thing is for the 6v6. A will be set to 8. So let's switch this to 8. 5. 6.3 volts because it's a 6.3 volt tube. 67 on the left potentiometer. 67, about there. And 25. That's pretty much all the settings you need to set it to. So what we did is switch A goes to 8, switch B goes to 5, the voltage 6.3, the left potentiometer 67, right potentiometer 25. Now, before we start testing anything, we have to make sure the line voltage is calibrated to the meter. And how you do that is, obviously we switched it on. I had it on for about 15 minutes now. We press the line button. On the line button, as you can see, there's a little line down here. And this little line reads line test. And you want to align that line test to the meter here. And you can adjust that by moving the line test while you press the button. As you can see, we adjust it to where it says line test. So it's about there where it says line test. And we switch this to shorts 1. And all we're worried about is the gas button and the test button for now. And that's it. Obviously there is the noise test probe here. You can plug in your noise test meter. Let me headphones. Let me bring out a headphone so I can show you what I'm talking about. Now this is an old school headphone type. And how this works is you plug in these two probes down here. See that? Where it says noise test. And that helps you determine if it's a noisy tube. And we can test that too as well. And you can hear the noise on here, I guess, from the tube. So let's just focus on testing the tube. So let's go ahead and plug this in. Let it warm up. As you can see, the tube is warming up. First thing we do is let it warm up. Once we let it warm up, I want to do the short test first. Always do the short test before you do the mutual conductance test. Because if this tube has a short and you do the mutual conductance test and don't pay attention to that, you can fry the transformer on one of these. So always follow that in that order. First, you do the short test, then you do the mutual conductance test, and that's pretty much it. There's this short test lamp right there. It's a neon lamp. You can see. Okay, so the first thing, run it across. Oh, that's okay. If it flickers, it's okay. As long as it doesn't stay on, we're good. So what we want to do is test. It's testing for short. So if there's a short in here, mind you, there's a bunch of you know how tubes work. There's a bunch of wires in there, and there's a wire shorted out in there. This will pick it up. See, no shorts, and then we go to tube test, and we press the mutual conductance test, and 3,000 is the minimum. So 3,000 back here. It's at 2,000. So it's still good. It looks like it's still good. So I guess 3,000 would be the standard mutual conductance at 3,000. We're reaching here a little over 2,000. Okay, and you can do the gas test. There's no gas. Not gas. If it was gassy, it will come up as a gassy tube. So that's pretty much it. Very basic, very simple. You just go ahead and do the line test. You can still do the line test while it's still plugged in. Adjust the line test to you see the line. Let it go. Put your first potentiometer to 8. Second 6.3 volts, and the first 6v6, whatever the indicator on the chart tells you. Same thing for the right one, and do the short test first. Run it back and forth. No shorts, as long as you can. It's okay if it flickers, as long as it doesn't stay on. Go to tube test. Hit the tube test. Looking good. So let's go to the next one. I have two of these 6v6. The second one. I don't remember where I got these tubes. I think I pulled them off of some test gear I had years ago. Let it warm up. Put this at a short test. Okay, once we feel comfortable it's warmed up, do the short test. No shorts. Set it for tube test. Press the gas. Doesn't come on, doesn't move. Test the mutual conductance test. Reads the same, 2,000. So I will conclude that these two tubes can be a matched pair. And that's it. So these tubes are, I would consider them a matched pair. And you can also see, look, they look like they came out of the same unit. They both have the same indication. I wonder if they have the same date code. Look at that, same date code. So yeah, matched pair. So that's how you test tubes on this Hickok 51X. Very basic, very easy. Just make sure you do the line first, adjust the line, put your settings to the chart you get on your chart, do your short test, press the, put your tube in, let it warm up, press the gas, make sure it doesn't, it's not gassy, and then press your mutual conductance. You get your reading according to the chart, and that's about it. Well, thank you so much. Real quick, I just wanted to show you how the noise test function works on this device. You can also test for noisy tubes. You have vintage audio equipment and you want to check to make sure that tube isn't noisy. There's a function on here or option where it allows you to test for noise. You have to use these old school 2000 ohm earphones, and you plug it in, and you plug it in, set the where it says short test. You want to move them around across the whole device of testing, and just listen for noise and how that works. Let me see if I can bring you in. Okay, I hope the camera can pick this up. I'll bring it. How does this work? I'm not sure if you can hear it. Hear that? And you put it at tube test, and it's quiet. So that's a quiet tube. And that's pretty much it. That's how you test for noise. You just listen to the noise. I'm gonna move it over to. See, you hear that? You don't care about this. What you care about is the tube test for noise. Keep it there, and then see how quiet it is. Bring it back to so you can hear it. Quiet. So that's pretty much how you test for noise on these tube testers. Great for testing noise if you have vintage audio gear and you want to test a tube and think it's noisy. Oh, another way you can test for noise as well is you can go ahead and leave it at tube test, and I like to hit it. See if you hear anything. Sometimes you'll hear ringing, which I don't hear any ringing, which is a quiet tube. There you go. That's how you test for noise. Thank you, guys.